for this. If my interwebs want to load. All right, this one, live control room. All right, sweet, sweet, sweet. Looks like everything is set up. Let me check the Discord. Who we got here so far? Where's the Discord? Okay, sweet. You all are rolling in right now. All right, looks like you guys are all rolling in right now. Hopefully, whatever, just, I don't know why Discord keeps geeking out like that. All right, sweet. So we're going to wait here for, what's up everyone on YouTube? We're going to wait here for another couple minutes for people to roll in. As mentioned before, audio quality, it's going to work. All right, it's going to work. It's not the best, but it's going to work for now because my microphone died. So it's dead. I think it died like a little bit a while ago because listening to the 3.0 stream for the new aimbot update, it sounded like that was the stupid webcam. So we'll see. We'll see. We'll wait here another couple of minutes for people to stroll in, and then we'll go ahead and start. So if you haven't gathered, today we're going to be talking about quantum computing and how to get started on that journey. It's quite interesting, quite fun. We're going to talk about what is quantum computing in general, and we'll get into literally using quantum computing and using a live quantum computer. Right? Hopefully they're not too busy right now. But yeah, you can use a real quantum computer. It's 100% free. Talking about that, I should probably go ahead and log in. So that way I don't have to sit here on stream and log into these resources. Where is it? So again, you guys, we're just going to wait here till like 12:05, starting at 12:05 my time. Oops, that is the wrong way. Right now it's 12:02, so in just a couple minutes while we're waiting, I'm just going to log into stuff here so everything can be sped up a little bit more. I'm so done with freaking Medium. Get out of here. Let's go ahead and sign into this bad boy. So I should sign into this one too. What's up, you guys? Welcome. Thank you for coming in. We're going to start here just in a couple of minutes. All right, we're just waiting for people to stroll in. Again, I'm just logging into stuff right now as people stroll in. So don't worry, we're about to start. And of course, they got new agreements. That one is bugged. Okay, we'll roll with that. I thought I've already filled this out, and I'm getting a phone call. Should I take it here live on stream? Sounds like a good live choice. No, send them a voicemail. I don't trust you guys. RootKit and continue on. There we go. All right, we're in the matrix. Let's see how busy their resources are. So in about like 2 more minutes, you guys, we're going to get rolling here. We're just going to wait for any last minute people to stroll in here. They are leaving me. Comcast is calling me. I don't even use Comcast. God, you know what? Side rant. I absolutely hate Comcast. All right. If you have Comcast, I'm sorry. If it's your only option, I'm sorry. Switch to Verizon as soon as possible. It is absolutely beautiful. I've never had a better experience than Verizon Fios. Absolutely amazing, flawless, no throttling, no BS, no nothing, and it was cheaper. It was cheaper. It's better and it's cheaper. It's insane. Um, all right, we got one more minute here, and we'll go ahead and start rolling up. Why is this not live? It should be live by default. Oh boy. Let me go and open up the chat here. All right, so if you're on the YouTubes, you can join the Discord and ask questions. The Discord is going to be more live than YouTube, but YouTube will have a better experience in regards to, because it's hooked up to Streamlabs and everything like that. If you're on Discord, you will just ask questions at any time in the public stage. We're going to talk about quantum computing today. So let me go and get rid of this. We're going to go and start, you guys. So today is all about quantum computing. Talking about what is quantum computing, why you would want to even learn quantum computing, how hard or easy is quantum computing, what resources are available for you, and who's the current industry leaders. All right. It's going to be a very, very fun, fascinating day. We're going to go through things very, very quickly. All right. And if there's still interest, we might do a day 2. Just so you guys know, previously what my quantum computing history is I've messed with quantum computer. I've tried to get my Qiskit cert. If you scroll down into the quantum computing channel, you can see from my one take, I wanted to redo it, but I got busy with life. I failed the cert by like just a couple points. All right. So I'm not a quantum computing professional. I do not do this full time, but I know enough to get you started, and that's all that matters. All right. So quantum computing sounds complicated, right? It is actually quite complicated. It's very breaking edge, and you're not going to find very much support out there about it. It's on you to learn and teach yourself. IBM is the #1 leading expert in this field. They publish the cert. They have the best library for getting into quantum computing. IBM literally gives you free resources. They have an amazing class, which we're going to be going through on how you can learn. So IBM is pretty much it. Specifically, their machines have the highest qubit count. Now, the qubit count is not as debatably as accurate as some of the others. In regards to their outputs and how correct it is, but it doesn't matter because their stuff has the most, which lets you do actually more real-world things compared to everyone else. So in quantum computing, its current state is the equivalent of early computers. All right, early computers back in the 60s, 70s, 80s. Where most of the time you're going to be programming in their version of assembly. All right, it's basically an assembly-like language right now. So if you know assembly or you dabbled with assembly, it will make more sense to you. All right, it will just straight up make more sense to you. If you've never messed with assembly, it's going to be quite a bit of an up curve for you. Additionally, if you know calculus, then that will help you. If you've been programming for any significant amount of time, you know calculus, whether you know it or not. To give you an example, if we use, I don't actually know if this assistant will work or not. In calculus, I didn't even spell that right. In calc, how would you write out a for loop for computing pi? Let's see if this works. It works on ChatGPT. It will like format it nicely and stuff. I wonder if it's going to do just the Python version. But basically, this is calculus. All right, this is calculus. If you look at the crazy symbols and stuff in calculus, they are pretty much just things like for loops and if statements and stuff like that. They just use wild, off-the-wall symbols that you may not be accustomed to, but trust me, you know what they are. So it's best for you to take a second to figure out what symbols are the equivalent to for loops and while loops and if statements and stuff like that from calculus, right? There is no actual really uptick in like what you have to spend learning for calculus if you've been programming for a while, because it is actually what you're familiar with. The reason why I bring that up is when you are going through and learning this, a lot of it is written in mathematical terms. So you're going to need to spend some time deciphering it. You can use things like ChatGPT to help you, your AI assistants to help you with deciphering. If you're not using your AI assistants, you should stop becoming a programmer. It's not for you, all right? If you're not going to use the latest and greatest that's available for you right now, you need to stop trying to become a programmer because everyone else is going to run circles around you. You should be using your AI assistants all the time. If you think it's cheating, then this is not the job field for you, all right? Okay, so quantum computing is specifically harnessing the power of quantum mechanics to produce computational results. It's good for things that are more analog, all right? Most of our computers are based off of binary, which give you binary-based answers. They don't really do analog stuff well. There are analog-based computers that even do analog way better. That's still cutting edge, and that's more so great for machine learning. And analog's not really the best term for it, but it's a good way to think about it. And by analog, I mean things that aren't, black and white. They are more things that really vary and have a whole waterfall effect when you change something simple. Think of it like machine learning. Quantum computing is great for machine learning. Think about it also about cryptography, so encryption and stuff like that. It's great for that. For medical research, for drugs and biology and so forth. You can actually mimic real-world biological systems to a certain extent on these computers because you are harnessing quantum effects that happen at molecular levels. All right. So quantum computing is amazing, and it can compute things tens of thousands to infinitely times faster than a normal computer can even get close to it, all right? But it is not meant for general computing, all right? It's the same thing like your graphics card. Your graphics card is great for processing graphics, but it's not something you're going to want to use to load up Chrome, all right? It is meant for doing floating point operations great. It's not meant for normal, like, I don't want to say binary based math, but non-floating point items, right? It's not going to be as good as a CPU, right? Same thing with quantum computing. Think of it like a graphics card, except a quantum graphics card. It's meant for specific things and speeding up specific operations. So encryption, it would speed up that significantly. Most encryption techniques right now with a quantum computer of significant size, what encryption? None of it is, for the most part, is post-quantum, secure. That's a big thing, a big push that the US government has been doing. I think they just released one of the latest versions of HTTPS, TLC or TLS or whatever it's called, to be quantum secure. That's the big thing if you are into Web3 and you're tracking crypto, is a lot of them are talking about being quantum secure or post-quantum secure, because a lot of systems in place right now, once quantum computers are big enough, and you'll know what that means here a little bit, they'll just break everything. Nothing is safe, basically. Nothing is safe. And still, most systems out there are not safe. Passwords that are saved on servers are not safe. They're not ready for post-quantum. Post-quantum is almost here. It's almost here. With IBM's newest release of quantum computers, it is almost here. It's starting to get achievable, and we'll get to that here in a second. So Qiskit is the library you want to learn. It's Python based, so you can pip install it. And this is a way for you to emulate a quantum computer on your computer. If you have a NVIDIA GPU, this is going to be great. All right, it will let you emulate semi-large quantum compute states. If you can only go so far though, because that's the whole point. You have to use a quantum computer instead. A simulator can only do so much because this grows exponentially in how much you have to compute. But a quantum computer is going to be way better. Their documentation and tutorials are A+. They will teach you literally everything you need to know in order to get your Qiskit cert, which you can then go and get a quantum computing software development job. It's just that simple, all right? You watch the tutorials, do the tutorials, you get your cert, and then you get a quantum computing job, all right? Those, like, people are freaking about how AI has changed everything right now. I'm telling you, quantum computing, once it's there, because it's still in the development states, it's going to make the advancements of AI look like nothing, all right? Because when this is actually to a production level, ready level, the advancements in AI and everything are going to be like mind-boggling compared right now. Like right now, you're basically messing around with toy cars, all right? AI systems and their current state are like toy cars. They're fucking nothing, all right? Once all of this is taken off, then you're looking at everything you've seen in movies, all right? So IBM just released a new, well, as you can see right here, a new version of Qiskit and everything on their IBM Quantum platform. So I highly recommend you logging into this. You'll have to make an account onto IBM's website here. But this will give you access to literally their simulators they have, which are the equivalent of you running it on your own computer, and actual quantum computing instances they have that you can use. So this is a 127 qubit system, a 7 qubit system, and it has some specs and stats. And if you click on it, it will give you some more details, specifically the error rate. This is the actual chip itself and showing you the actual error rate of each one of the qubits in their chip and their current error rate. I'm not familiar with the coloring scheme. It's been a while since I've been messing with this. But yeah, no, this is all real. So basically, people are used to core counts on their computer, like 1, 2, 3 core, multi-threaded core, etc. Qubits, it's not really quite the same. Qubits are kind of like normal bits, right? They're quantum bits, so they can be in potentially a bunch of different states. But when you run a application, unlike a normal computer where you can just have a super long program and just run it and it will compute step by step by step, when you're building a quantum circuit, you actually have to build out the whole thing. And if it takes 500 qubits to build out the system that you want, that means you need a 500 qubit system to execute it. If there are none available, which there are none right now, 127 I think is the largest that's available right now, it means that you simply can't run that circuit. You can theorize on what it would do, but you actually can't run that. That's the issue right now with quantum computing, is a lot of the big papers and systems people want, specifically like people like Google, AWS, to start using this in machine learning, they need thousands of qubits at once to be used for their systems. So until we're in the thousands and thousands of qubits realms, pretty much nothing is really that practical for utilization of quantum computing, unless you know how to really utilize these bits to the max. You can see here there's 1,000 jobs running. So running on the 127 system, which is free, you might be waiting for a little bit compared to one of these smaller systems, 7, all right? So these are live quantum computers, again, that you can use. Now, I don't recommend using them for the most part. Just use your own computer, all right? It's going to be able to run just about everything you want. Also on here, we can go ahead and check out their learning resources. And this is where you basically want to start. Now, I'm going to take you guys through this site, because I have personal experience with this site. This is what I learned up on before I took my certification exam. But I would recommend you to use this site, which is their latest and greatest. I think they've upgraded everything to nice video lessons, which is really, really nice. So I definitely would recommend you guys checking it out. And they list, it's all free too. It's all 100% free. All right, they're listing to Khan Academy and a bunch of other YouTube channels for you to learn some of these fundamentals. Again, if you're not a math nerd, but you like programming, don't worry about it. You've been doing math whether you know it or not. You built a game, great. You are actually a calculus god. You just have no clue about it because you're not used to the calculus symbols. Once you learn them, hey, you'll be good. We'll probably see some here in a second. So we're going to go through this and check out some of the tutorials here. So to get Qiskit, it's very, very simple. All we're going to do is we're going to pip install the Qiskit. Hopefully I spelled it right. There you go. Pip install that, and then you're good to go. You pretty much have a quantum simulator right on your computer, ready to roll in Python. If you don't know Python, you need to learn Python. Come on, why don't you know Python? Everyone knows Python. It's used for a reason. It's one of the best languages out there, all right? So while this is installing, let's go and go back. So this is kind of the mathematical stuff you're going to have to be learning. Now, you don't need to know everything up front. You can learn it on the job. All right, you can learn on the job. Their docs are really, really good to explain what all of this means. All right, what all of this means. In quantum computing, you don't really typically compute results, like results in the way you think of it. Like if I add 1 + 1, it's going to equal 2. No. In quantum computing, it's probability. It's all probability based because you don't know, because in quantum systems, it's all based off of probability. Is it what percentages of it to land in this area compared to this area? Because everything around this whole entire mystic field of quantum computing is still being discovered and found out and tested on, and it's still like, this is very much the cutting edge. So everything is based off of probability. So if you have this is how to make a 3-qubit large quantum system. So this is a 3-qubit circuit. If you wanted to see what the probability is of them all being zeros or all of them being 1, this is the equation. You can use it if I'm remembering. I'm just guessing right now. It's been a while. Additionally, you'll need to learn about different types of gates. All right, just like if you were doing assembly. All right, you have the same type of operations here that you'll have to perform in quantum computing. You'll have some new ones like the H gate, which is for the Hadamard, which puts things into a superposition state, which means that it's pretty much 50-50 on whether it's going to be a 1 or a 0 in the bit state, because it's superposition. If this is all new concepts for you, if you've never heard of the term superposition before, all right, or Bell state or other various things like that, I highly recommend, of course, I'm going to say use your AI assistants, but also utilize YouTube. There's an amazing channel by PBS Spacetime. All right, PBS Spacetime. I'm forgetting the guy that teaches it, his name. This guy right here, Dr. Matt. Watch his stuff. All right, he has a bunch of playlists, a lot of videos here. Watch his stuff specifically on quantum computing, and don't just watch it once. Watch it over and over and over again, and eventually it will make sense, because it's going to hurt your head a lot at first, because a lot of these things don't really make sense at first to someone. Why wouldn't something be definitely defined? Why wouldn't it be just it or it is not? It's not. It's all probability based, because we don't know, because it's just there's just so many unknowns. And again, I'm not a PhD in quantum, all right? So definitely they'll use the more precise terms. I'm going to be using the more dumbed down general terms, right? But watch this and watch a lot of it. It will actually make a lot of this make a lot more sense to you. So let's go ahead and make our first own quantum circuit here, shall we? Let's go ahead and go here, and that's not the one I want. So if we go over here, it's quite easy. We just need to import. Also, if you're not familiar with NumPy, you should definitely utilize NumPy. So we can go ahead and create a quantum circuit here. So this is going to have 3 items in it. And we'll additionally go ahead and do this logic here. So this is going to put the first item, the first qubit into an H gate or through an H gate. Then next is going to C naught it. And then this one's also going to C naught it. All right. Basically, this is the Bell state is putting it into an entangled state with another qubit, which means that, again, quantum computing wizardry. Basically, when you're in an entangled state, whatever this bit is going to be, this one will also be it. They will be physically linked to each other. All right. How, why, no one really knows. All right. No one really knows. But they will be physically entangled with each other. So no matter what your answer is on this, the answer will be also mimicked on this one. All right. So let's go ahead and let me see if I can get the drawing hopefully working here also, because that would be super nice. Let's go ahead and Python main this. I wonder if it's going to, pip install this bad boy. Let's go ahead and pip install this for matplot. Oops. What is going on here? Cancel, cancel, cancel. Oh, I have an underscore here. Let's go ahead and get rid of this. So this is drawing with matplotlib. I think it will show up as an image because we're not in a Jupyter notebook. I highly recommend you using a Jupyter notebook if you're going through this. I think I have a plugin here for making this into a Jupyter notebook automatically, but I can't remember right now. Let's go ahead and go in Python main. Oops. And we'll get our results here. Actually, we're not even probing for results. So what's happening right now is we set up a quantum circuit. We fully set up a quantum circuit for emulation, but we never actually ran this circuit because we have to give things an initial state and then run it. Basically, what we're doing is we're just making the circuit and then trying to draw it out to screen, but we currently can't draw it out to screen. So I wonder if I can just have it as a file name. I wonder, can we just use the simulator? Because they used to supply a Jupyter notebook that you could use. Sorry, guys. I didn't come too prepared for this because it's mostly just showing you guys the one-on-one, and then basically based off how everyone feels, then we can do stuff. So they literally have quantum assembly. I'm not joking when I say this is like assembly. There's quantum assembly, that's QASM, and then there's the Qiskit library built on top of it. You can learn either one, but I recommend using Qiskit because it will just output. All right, it will output the quantum assembly for you. So the circuit that we built earlier is going to be using this gate right here, which you can see is going to set the probability to 50-50. So this bit is going to be either 50%, has a 50% chance of being a 0 and 50% chance of being a 1. And I think it was this NOT gate, or was it this one? I think we'd use 2 of these ones. I think this is the circuit we have right now. It looks like it. Can you edit this now? No, you can't edit this now. And we can set up and run. Perfect. Except we need a compute resource. Okay. let's go ahead and use our assistant to see if we can draw this out. How to save the image to a file. All right, let's see right here. Draw MLP says we can just do this. Let's see if that actually works. I don't think it will actually work, but we'll go ahead and try it. Let's rerun this, and let's see if we get our circuit printing out now. I think there's another option here we can use, but we'll see. Oh, look at that. It drew it out. Okay, so similar to what I drew here a second ago. So again, this is your, I don't know why I want to call it the Hasselblad gate. It's not Hasselblad. It's the H gate. This will put it into a superposition. Again, these are going to be your NOT gates. So this is going to be the opposite of, it's a control NOT gate. That's what the C is for. So it's going to be the opposite of what that item is. So just like what you're used to, a NOT gate. And you can see how everything is written out. Everything is based off matrices and probability of those matrices and each one of those items in the matrices. Again, it's a lot of technical terms you're going to be going through here and seeing. Don't get overwhelmed by it. Just reread it. Use your assistants. You're used to a lot of this stuff already by programming, right? You don't need to be some quantum expert to get your certification on this. Your job as a programmer is to be given things by PhDs who sit in their basements and smoke crack and do this stuff, all right? Your job is to take what they produce and then turn it into code, right? So as long as you get the cert and you understand the gist of it, if you're given stuff like this and you can understand the gist of it and you can convert it into code, then you're going to be good, all right? You're going to be good. So yeah, you can also output it into latex if you know what latex format is. Some of you guys should know it. That's the scientific, like the standard. But there's just different ways you can visualize everything because again, these are actual like physical quantum things and quantum states. So I forget what exactly what exactly they are that you're measuring, like what type of atoms they are. But they're like physically moving around. They're physically like doing things. So you can visually check out these items in a 3D way, which is what you saw here through this Q sphere right here, where you can see, you know, what the state is of everything. And right here, this is another way to visually indicate in 3D space how everything is, how it's oriented, the current spin, etc., different probabilities of it. All right. So again, this site will teach you literally everything you need to know in order to get into this. All right. You're going to have an advantage. Oh yeah, the measure is what measure is how we can actually take a measurement. So let's go ahead and take a measurement on our circuit here. Let's go that, and then is this going to tell me my output? Again, it's been a while. Oh, here we go. Jobson. We got to simulate. You know, I'm not going to do that right now because it might be a little broken. There's a bunch of different simulators you can use, including you can utilize the IBM simulators right in your code, right? Let me go and rerun this. You'll see basically where you're taking measurements. Now, this again is a part of the weirdness of quantum computing, is specifically the measurements, index 0. I'm not quite sure what's going on there. But the madness of quantum computing is you can put whatever. You can put things into certain states, but you guys have heard the Heisenberg uncertainty principle, right? So pretty much cat box, you don't know if it's dead or alive. All right. Same thing with these systems. All right. You can set up your systems to automatically compute. They'll automatically compute like magic, but you're not allowed to ever look at what the results are until like very certain points. All right, because when you check out the results, you'll collapse the whole system. Specifically, the entangled states, the different probabilities that in, you'll collapse it to choose one of those probabilities. So one of those probabilities will be chosen. So if you have a 40% and a 60% of it being a 1 or a 0, that is always up in the air and is always changing until you take a measurement. Because from these quantum systems, when you take a measurement, the measurements, I don't know if destroy is the correct term, but it's a destructive process, all right? Because you can't, these systems are just so small, you can't actually just observe them without destroying basically the magic behind it, because you have to physically prod it. And when you physically prod it, you're basically stopping everything that's going on. So a lot of it, again, is going to be you thinking through and setting things up prior to you taking a measurement, and only taking a measurement when you actually need to take one. Again, that's why quantum systems aren't good enough right now for machine learning and stuff like that, because when you set up a circuit, you may need a circuit that's 500 qubits large, and you can't just compute 100 qubits at a time and move things over, because when you take a measurement, and that's the only way you can move things over is if you measured things, it just destroys. It destroys the quantum state. What questions do you guys have so far? Because this is just about everything I've wanted to go through so far. Again, I highly recommend you guys using Jupyter Notebook when you're going through this stuff, because you'll get the visual printouts, but also you don't have to regenerate your quantum circuits every single time, which will speed things up. You can just do slight modifications. Use your AI assistants. They're going to help a lot. If you know assembly, that's going to help a lot. Pay attention to everything on their sites, all right? On all of the tutorials they give you, everything here, and then spend additionally time. This is, knock on wood. Everything they teach you will get you to 90% way there, right? For passing the exam. You need to also, you will not pass the exam like me, all right? You won't pass it if you just learn everything on the site. You will also additionally need to spend time looking through and learning the library and some of the options in the library they may or may not talk about here in the docs, all right? That's one of the reasons why I lost a couple points is a couple of the questions they asked specifically were about things in the library, I think specifically for visualization that I never used before and they don't really talk about, but are things that are in the library. So make sure you also spend additional time looking through the library, all right? But look, I'm no PhD. I have no college degree, all right? You can do this, all right? If you're determined enough and you're willing to let your brain break and hurt a bunch, you can learn everything here. You can get the certification, and then you can get a job doing quantum computing. Now, where's the IBM Qiskit certification? Why are these all sponsored? There you go. So they got their certification right here that you can take. This is for version 0.2. I don't know what version they're currently on. Let's go see. They're on version 0.45. So this one is going to be outdated. So I wonder if they have a additional one or what's going on with that, because that is a little outdated. But you can look into it more. All right, you can look into it more. Right now, the biggest players in the quantum space are obviously going to be IBM. All right, they're rolling out next year. I believe it's next year with their newest and largest quantum computer yet. Google, but Google's kind of hush-hush. AWS Quantum. The biggest thing you can see the quantum players is if you go check out quantum cloud resources. So it's going to be IonQ is going to be another one. And let's see here. So IonQ, Rigetti. This is one of the biggest players in the space also. So you can check out their websites for job postings and what they're looking for specifically. So let's go, I don't know, for example, to IonQ. I think IonQ does not use Qiskit. At least it's been a while since I've looked into this, you guys. So let's go and check out their site. IonQ job openings. Because I believe they had their own language. Because again, this is all like cutting edge, so everyone wants to be the god, the goat, the person that's making the libraries and standards that everyone's using. So let's go ahead and look here at, I don't know, one of these jobs. Remote and Jupyter Notebook, machine learning. Here we go, Qiskit. Oh, I think Circ is the other one. So hands-on experience with Qiskit, great. If you are using Qiskit right now and you're learning it and you're able to get one of the certifications, you have, what other hands-on experience is there with Qiskit? How are you supposed to get job experience with that? You're not. This is such a small field. There's probably 1,000 to 10,000 devs in the world that have ever done anything with quantum computing on this level, right? In the world. There's not going to be help blogs, no forums. You can't go to Stack Overflow for this stuff, all right? So you, passionate, learning on your own time, bam, there you go. You're going to definitely want some of these other ones. This is for a principal role, so you might not, you might not be prime time for a principal role, but they're definitely going to have, what do you call it, more, maybe not junior positions, but definitely more junior positions. Because the most part for them is juniors need to learn too much, all right? And they also don't know how to figure things out on their own. So you're going to see that a lot of the jobs in the cutting edge are specifically going to be asking for seniors, even though there's no such thing really as a senior person for utilizing these quantum systems because they're just so brand new. The thing they're looking for is you're actually a senior dev, because senior devs can figure things out, right? If you're sitting here wanting to learn these libraries, then you're on your path to be a senior dev or higher if you're not already, because you're the ones that are sitting here asking questions, attending classes like this, looking things up, all right? If you want to know exactly what you want or how to get into a certain job, don't Google it. Don't ask idiots on Reddit. Go to the fucking job listings. All right, here's IonQ. Here's what they're looking for. Go to Google, go to Rigetti or whatever it was called. This is just through AWS, but again, like I said, IBM is one of the leaders in this space, so I would check out their stuff. I would check out Google Quantum jobs. All right, go check out those ones, see what they have listed here and what they're looking for, and then train yourself based off of that, and then shoot over your resume and see what is available. Because as you can see here, there are a lot of job positions opening. There is a dev shortage. There's been dev shortage for years. People are desperate for devs. So even though you may not be as qualified, still apply. You might actually get the job anyways, because if no one else is applying, then they might just go with you. What questions, comments, concerns do you guys have before we wrap up today's stream? While you guys are asking questions, the cool thing for Chat GPT, I usually use the API stuff. I don't actually use the Chat GPT product, but I did use it today just to see if it will actually compute or format things correctly. So right here, use it to figure out the calculus version of things and then undo the calculus version of things. I don't know if this is actually a good enough question to ask it, but the I don't even remember what the hell this thing is called in calculus. But this is the equivalent of your for loop, all right? This is actually a while loop because it's going to go. It starts at n equals 0 is your starting point, and infinity is your ending point. So this is going to literally loop. This is a loop that loops forever, and just like your normal loops, you know, every time it loops, n is going to be 0 the first time, 1 the second time, etc., etc., etc. All right, you're already used to this if you're programming. All right, you are literally doing calculus. So it's when you're doing stuff like this, don't get too overwhelmed. When you see all these weird equations and everything here, don't get too overwhelmed with it because it is a lot simpler than you would think. Right, a lot simpler than you think. Let's see actually how familiar ChatGPT is with quantum systems. Let's go ahead and grab this. What does this mean? All right. Over the sidebar. Oh, look at that. That's pretty good, actually. It does know what it means. So use this, all right? Use this. You can sit there, and once it gives you an explanation, be like, can you explain this like I'm in grade school? All right? And now you got your own teacher here, all right, that's going to know and tell you just about everything you need to know. It's accurate for the most part, asterisks, right? Don't trust everything. Again, I wouldn't personally trust it with this output because I don't even know if I asked an appropriate question. So I don't know if this is right either. The only way you would really figure it out is either confirm it with another paper online or just make this into an actual program in Python or something and run it and see if you're actually going to get proper outputs for Pi. But you can see here, it will sit there and try to explain it to you in a dumbed down version. So make sure you're using this in learning about things because there are the normie terms like entanglements, and then there's more of the technical terms, all right, that they have here in the docs. Any questions? I thought you guys would have more questions. Any other questions on how to get started or I don't know, anything in regards to that? I can send in here, let me go and post these links here into the Discord. Again, I haven't used their new learning resources. I've used this site, but you guys should definitely check out their new resources. I just haven't had time. This is a passion side thing for me. But I've just had no time. So you can't really do everything in life. You gotta choose certain things. So sadly is probably one of the things I won't get around to doing too much of. But I definitely encourage you guys doing it because this is where big money is gonna be in the future. Big, big money. I can't stress enough how significant this is gonna be in about 10 years, right? This along with Web3 stuff. So crypto stuff, it's absolutely massive. Most banks are actually using crypto stuff, whether you know it or not, right? Those are like the two big things along with AI. Those are like the three pillars, I would say: AI, crypto, and quantum. Like choose one and roll with it. Those are the big boys. Those are the big players that you definitely want to know about. I don't see any other questions. If there are no other questions, I'm going to go ahead and end the stream, you guys. So if you have anything else, this is your time to ask, or we're going to end the stream. I'll see you guys next week. Again, next week we're having December 1st, our hackathon. All right, we're not doing a Hack the Flag this year, but we're going to do a hackathon. It's going to be for all of December. It ends at the end of the year. We're going to do $150 of prizes. So make sure you guys participate. It's suitable for everyone of every skill level. We're looking for creativity. So on December 1st, we're going to be posting that. And then on December 2nd, we're having another AI aimbot Q&A. So if you have questions about the aimbot, make sure you join in for that, right? And then after that, we're doing a live dev session where I'll be deving live an update for the New World bot, right? Let me see here. All right, I don't see any other questions, so that's all I got for you guys. So I'll see you guys on the next one.